Good morning, Sooners and Catamounts. It is I, Mr. Martin, live from my home. As you can see from, well, at least one of the decorations in the background. This is not my personal room, but it's my little corner where I can go record. So I had to commandeer Miss Martin's room for a little bit based on the decoration. All right. Today is Monday, uh, November the 16th, 2020. 2020 still. Hope that you're enjoying your morning so far. Hope that you enjoyed your dear time, seeing and 10 if you guys were able to watch it, and your weekend, of course. I hope you enjoyed that as well. But it's time to get into math. So, guys, at times during this video, you will likely need to pause if you need more time. For the sprints that we're going to do, I'll go ahead and play the timer or I'll run the timer for you. But for other things, guys, if you need more time, just pause it. My scholars in person, when we do the problem set in your Blue Spine Eureka book, you guys have it. So you won't need to see it. But you guys at home, if you do not have your Blue Spine Eureka book, simply pause the video because you guys are going to be doing this independently and asynchronously as well. So you should be watching this video on your own time as best you can. Sorry, God, it's going to change a little because the sun in the background is changing the white balance. So that's what you're seeing, guys. I'm not ascending to the afterlife. So anyway, guys, um, we're gonna start off, and I'm going to switch my camera here with some some problems in parentheses. I'm gonna give you a couple of minutes to get these done. So this will be your first example of, I'll give you a little time to do it. If you need more time than what I'm allotting you, simply pause the video and continue. All right, so I'm gonna put 2 minutes on my timer. Make sure my phone's on silent so no one accidentally calls me. 2 minutes on the timer. Go ahead and solve for A and for B. How about a minute and 10 seconds remaining? Remember, guys, you should be writing these down on your scratch piece of paper with your pencil, not just sitting here waiting for them to be solved. The workload is on you guys today. I'm going to guide you through this learning, but you are going to help yourself learn today. All right, that's time. That's time. Remember, if you need more time to do this, guys, simply pause the video and solve them before I show you the answers. Don't just try to glean the answers off of me, guys, because that opportunity won't be afforded to you when it's time for you to show your knowledge on an assessment. So let's look at these, guys. Remember, when we see something in parentheses, that is what we do first. So even though these problems are read the same, 5 times 9 minus 6 equals 5 times 9 minus 6 equals, we're going to get different answers because the parentheses are telling us to do different operations first. So since the parentheses are covering my 9 minus 6, I will do 9 minus 6 first. And if I pass first grade, which all of you did, you should know that 9 minus 6 is equal to 3. one, by subtracting, but also by knowing that if I take 3 and add it to 6, then I would get 9. So if I do the inverse or do it backwards, then 9 and take away 6 will give me 3. Am I done? No, I'm not. I still need to bring down what was not in my parentheses and then finish my problem. So 5 times 3, well, if I know my 5s, 5, 10, 15, or if I know my 3s, 3, 6, 9, 12, 15. Because I know that 5 times 3 and 3 times 5 are both going to equal 15. So A equals 15. A equals 15. Pat yourself on the back if you got that one correct. Pat, 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 pat. All right, let's look at B. So the parentheses have changed. Like I said, the problem, the way we read it has not changed, but the way that we solve it has definitely changed. So now we need to do 5 times 9. So maybe I know my 9s, maybe I don't, but I definitely know my 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45. I'm holding up 9 fingers. I counted by 5s. 5 times 9, which would be the same as 9 times 5, is 45. Also, guys, remember the 9s trick I showed you last week. All right, if I have my fingers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, this is 9 times 5. So I will put down my 5th finger. 1, 2, 3, 4, 5. This is my 5th finger. I put it down. I've got 4 on this side, which would be my 10th place. So 40, and 5 on the right side of my finger that's down. So 45. All right. Then, am I done? No, I still need to take away that 6. That's a part of the problem. So 45 minus 6 equals B. Well, what does B equal? Let's find out. What is 45 minus 6? Now, I could stack this vertically, guys, but it's a single digit number. Let me just use my fingers. So starting at 45, taking away 6, so 44, 43, 42, 41, 40, 39. I took away 6 from my 45, and I'm left with 39. B equals 39. So just like I've been showing you guys, those parentheses can change the whole problem. They can change the whole problem. All right, ladies and gents, we are going to move on with our lesson. By now, you should have done the multiplication fluency quizzes, which was on Schoology under the Monday folder for today. You should have already done that. That should have come first. So you should be watching this video second. So we're going to move on with our lesson objective. Let me first start my PowerPoint. Then I will share my screen to show it. All right, share screen, PowerPoint. Let's continue. All right, ladies and gentlemen, our lesson objective for today. Let me change this camera too so you don't have to look at this. You can see my face. There I am. All right, my lesson objective for today. I can solve two-step word problems involving all 4 operations and assess the reasonableness of the solutions. All right, so repeat after me. I can solve two-step word problems involving all 4 operations and assess the reasonableness of solutions. All right, ladies and gentlemen, this simply means that you are going to have the ability to not only solve two-step word problems using all 4 operations, that's addition, subtraction, multiplication, division. I can't really do that with one hand, but you know division, we're dividing things up, we're splitting them up, right? And assess the reasonableness of the solution. So to basically look at your answer and know, okay, this answer is reasonable, it makes sense. So if we start with a total, for instance, and then we divide and then subtract, we know that our final answer should be something lower than the total we started with. That would be reasonable. It would not be reasonable if we start with a total and we're supposed to divide and then subtract, but somehow our final answer is bigger than the total we started with. That's not reasonable. So we're going to look at these problems and also assess or determine how reasonable they are, how much sense do they make, right? Well, before we do that, grab your yellow spine Eureka book. You should have it near you. You should always have it near you. Guys, but I'm going to give you about 30 seconds while I set this up. The timer for you to grab your yellow spine Eureka book. You are going to have 2 minutes. We're doing 2 sprints today. In your yellow spine Eureka book, when you have it, go to page 99. Go to page 99. We're doing 99 and 101. Turn to page 99. As a matter of fact, I'm going to set up a timer here on my computer. Make sure I'm sharing my sound so you can hear it. 2 minutes. All right, you won't be able to see the timer, guys, because I do need to leave the, when I show you the problems, I need to leave them on the board for those that don't have the yellow spine Eureka book at home, but you will be able to hear when the timer goes off. All right. So we're going to start our sprint, yellow spine Eureka book, page 99, sprint A. All right. Oops. Get started in 3, 2, 1, and sprint. About a minute and 45 remaining. Filling in those blanks, guys, finding the unknown. You have about 1 minute remaining. Keep going. You're doing great. You're doing great. Remember, speed and accuracy. And accuracy. 30 seconds. Ten seconds. All right, time's up, time's up, time's up. Don't know why I didn't make a sound. Don't know why I didn't make a sound, but maybe you heard it on your end. All right. All right, guys, let's move forward. Let's look at what our answers were for this sprint A. I'm going to give you about 30 seconds. This is going to be another opportunity. Please pause it if you need to. Please pause it if you need to. If you didn't get to check all your answers for accuracy. I'm going to go ahead and give us a minute instead of 30 seconds. All right, guys, about 20 seconds. All right, that's time. Go ahead and set up for sprint number 2. I've already got my timer queued up and ready to go. Page 101, so it's the next page. Go ahead and get started in 3. Remember to pause if you didn't get to finish writing down these answers, guys. 2, 1, and sprint. About 20 seconds remaining. Remember, right after, we're going to have a minute to check it. Sorry about the sound in the background. All right, that's time. Go ahead and check your answers. I'm going to post those right now. About a minute to check them. Pause it if you need more time. Twenty seconds remaining. All right, ladies and gents, we're going to continue and move on. We're going to continue and move on. Okay. All right, ladies and gentlemen, now it's time for our concept development. Remember, we are dealing with multi-step problems. That means problems that have more than one step. That means we're going to not just add, not just subtract, not just multiply, not just divide, but it's going to be 2 out of those 4 that we're going to be doing in our problem. So let's look at our first problem. These can be tricky, ladies and gentlemen, but if you really pay attention to what the problem wants, it will help us find our answers. So let's never forget what the question is asking us. And until we find the answer to that question, we're not done with our problem. All right. Here, the first one says Joe has $173 in the bank. He earns the same amount of money each week for 7 weeks and puts this money in the bank. Now, Joe has $208 in the bank. How much money does Joe earn each week? So we know that Joe starts with $173. We know that at the end of his working weeks, his 7 weeks of working, he has $208. What else do we know? We also know for these 7 weeks, right? For the 7 weeks, that he earns the same amount of money each week. The same amount of money each week for 7 weeks. So those 7 weeks, he earns an equal amount, that same amount. Week 1, he gets that amount. Week 2, he gets that amount. Week 3, all the way to week 7. So what we want to know is how much money he earns each week. Well, the first thing we need to know, the first thing we need to figure out is what? I'll give you about 15 seconds of think time. We know what he started with. We know what he finished with. But what do we need to know? If you said we need to figure out how much money he made in those 7 weeks, then you are correct. Remember, he didn't make 173 in those 7 weeks. That's what he already had. He didn't make 208 in those 7 weeks. That's just what he finished with. So to find the difference between what he started with and what he finished with, to find the difference, remember, I've been telling you difference is a key word that tells us to do an operation. We need to do what? We need to subtract. So I'm going to change my video screen. I'm going to stop my share for just a second. All right. So I know he started with $173 before he started working. I know at the end of his 7 weeks of work, he had $208. All right. And I know that he worked for 7 weeks and he got the same amount for 7 weeks. 1, 2, 3, 4, 5, 6, 7. He got the same amount for 7 weeks. But what I don't know is two things. One is going to be my first step. So my first step, I need to find out how much money is this that he made in these 7 weeks all together. Then I can chop it up week by week to see how much he made per week because that's what I want to know at the end. So the first thing I need to know is how much money he made total, M. And to do that, I need to subtract what he ended up with minus what he started with. And that'll give me whatever's in the middle. So let's do that. Let's subtract 208 minus 173. All right. 8 minus 3. Can we do that? Yes, we can. 8 is larger than 3. So 8 minus 3, 7, 6, 5. 0 minus 7. Some of you will tip it to put 7, but some of us are like, no, Mr. Martin, no, Mr. Martin, we can't do that. We can't take away 7 from 0 because there's nothing there. So we need to decompose by going next door. I need to borrow this here. So this 2 becomes a 1, and this 0 becomes a 10. 10 minus 7, can I do that now? Yes, I can. And if I paid attention in first grade, I know that 10 minus 7 always equals 3 because 3 plus 7 equals 10. 1 minus 1 is 0. We don't have to break down that 0. We know how much money he made in those 7 weeks. He made $35. So M equals $35. Am I done with my problem? Am I done? Let me check. Let me check. What is the question? The question says, how much money does Joe earn each week? Not how much did he make in the total in those 7 weeks, but how much does he earn each week? So we are not done yet. We finished finding out how much money he made all together, but now we need to split it up into 7 weeks. How will we do that? I think you already know. If you said we need to divide, you are correct. We can't multiply. If we do 35 times 7, we're going to get a bigger number. If we add, we're going to get a bigger number. But that keyword each tells me that I need to split it up into 7. So 35 divided by 7 will give me how much money he made per week. So I'm going to use W to represent per week, how much money he made per week. Well, that should be easy, guys, because I have my 35. I already have my 7 weeks chopped up here because I was smart enough to model it. So now I'm going to put a dot in each week or a dollar in each week until I get up to $35. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. If you're telling me stop, you are correct. I distributed the dollars evenly. And how many dollars are in each week? 1, 2, 3, 4, 5. I found out that Joe made $5 each week. Joe made $5 each week. Is that what I wanted to know? That how much money he made each week? Well, let me check my problem. How much money does Joe earn each week? That is what we wanted to answer. So that is our solution, $5. Is that reasonable? I believe it is because we know that our answer could not be bigger than either one of our totals, and it is not. It was not bigger than 100, or yeah, it's not bigger than 173, wasn't bigger than 208. Couldn't be, because that's how much he has now. So, and it also could not be bigger than 35, because 35 is what he got in all 7 of the weeks, and we just wanted to know what he got in 1 week. All right, so $5 is what Joe earned every week. Guys, if you read the problems and not just model them, but understand what it's asking you to find and understand what these numbers stand for, then these multi-step problems will not be difficult for you. But if you're doing it the old kinder first, second way of, all right, let me just look at whatever numbers are in these sentences, not even read them, and let me just add them or subtract them or something like that, you're not going to do that as well as you think, ladies and gentlemen. You're not going to do as well as you think. So we got to understand what these numbers are telling us and what they mean in the story. Let's move on to our next problem. All right, guys, so the next thing we're going to do is move on to our problem set. I know there was only one example problem, but you already know that I'm going to do an example problem for us in our problem set. So turn to page 109 in your Blue Spine Eureka book. Actually, I think this one, number 4, might be found on 110. So go to 110 in your Blue Spine Eureka book and go to problem number 4. Go to problem number 4 in your Blue Spine Eureka book. And like I see some of my in person scholars do, go ahead and circle numbers 1, 2, and 5, because you already know you're going to come back to those after I do number 4 for you. All right. I'm going to give us one more really good example before I allow you to work on these for yourself. I know you're going to do great, guys. Remember, pay attention to what the numbers are representing. Not just the numbers, but what do they represent? What do they represent in the story or in our word problem? All right. So I'm going to move on. If you need extra time, just pause it. Always just pause it. Also, if you need another example, guys, since this is a video, go back to my first example, watch it again, watch it again, and slowly and pausing at different points, look at those steps again, guys, and trust me, it'll help you. But let's move on to number 4. All right, here's number 1 and 2, but we'll come back to those. Let's go to number 4. It says Tanner's beaker had 45 milliliters of water in it at first. 45 milliliters of water in it at first. All right, so that's what he started with. We stopped there. We're already seeing in our mind 45 milliliters in a beaker at first. After his friends poured in 8 milliliters, the container or the beaker contained 93 milliliters. So let me read that sentence again. After each of his friends poured 8 milliliters, the beaker contained 93 milliliters. So not just, they didn't just add 8 milliliters, every single friend. So friend number one put 8 milliliters, friend number two put 8 milliliters, all the way until they got up to 93 milliliters. All right. How many friends poured water into Tanner's beaker? So we're dealing with something similar, guys. So they started with 45. All the friends said, all right, here I have 8 milliliters. Let me pour it in. Nobody went twice. All right, so all the friends got one turn putting in those 8 milliliters. And then when they were done, there was 93 milliliters. So this is very similar to our first problem. So I'm going to stop my share and we're going to look at it. All right, I know that Tanner started with 45 milliliters. Don't forget milliliters is lowercase m, capital L, 45 milliliters. Okay. And then he, after all of his friends each put 8 milliliters in, there were 93 milliliters. 93 milliliters. So we know each of the friends put 8 until that there were 93 milliliters. Okay. So the first thing we need to know is how many milliliters is this, just like in our first problem, in between 45 and 93? To get from 45 to 93, how many milliliters would I have to pour? Well, if I want to know the difference between two numbers, what do I need to do? If you said subtract, you are 100% correct. I need to subtract how much he finished with from how much he started with to find out what this number is in the middle, how many milliliters it took to get from 45 to 93. All right, so let us subtract. Sorry about the blurriness, ladies and gentlemen. I'm trying to fix that up. All right, that's better. Good. So 93 minus 45. Sorry, ladies and gents. Hold on. Let me stop my video just a second. All right, let's see if this works. All right. 93 minus 45. Sorry about the blurriness, ladies and gentlemen. It is not your eyes. Document camera doesn't love me right now. It doesn't love me anymore. All right, let's hope it kind of stays like this. All right, so 3 minus 5, can we do that? No, we cannot do 3 minus 5. We need to borrow from the tens place. We need to decompose that 9, turn it into an 8, and turn this 3 into what? A 13. Now can I subtract 5 from it? I sure can. So let me start from 13. 12, 11, 10, 9. 8 and 8 minus 4. If I passed first and second grade, I should know that 8 minus 4 is 4. They poured 48 milliliters into the beaker that already had 45. 48 milliliters. Are we finished with the problem? Well, let me go back and read what it says. It says how many friends poured water into Tanner's beaker. We don't know how many friends. We just know how much that they poured into it. We know how much that they poured into it, but we don't know how many friends there are yet. Well, let me go back and see. What did it say about them pouring in that water? It says after each of his friends poured 8 milliliters, the beaker contained 93 milliliters. So I am going to put 8 milliliters into or I'm going to, the boxes in my tape diagram are going to represent his friends. I'm going to put 8 dots or 8 milliliters in each of those boxes to represent the amount of milliliters each friend did put into the beaker. And I'm going to stop when I get to 48. I'm going to stop when I get to 48. All right. So friend number 1, 1, 2, 3, 4, 5, 6, 7, 8. All right, friend number 2. I already know for 8, I'll need 2 rows or 2 columns of 4 or 4 columns of 2, either way. All right, so I'm not going to count 1, 2, 3, 4, 5, 6, 7, 8 every time. I'm going to keep start off from where I was so I can get to 48. So I'm at 8, 9, 10, 11, 12, 13, 14, 15, 16. Notice every time I end one of my tape diagram groups, I should be at a multiple of 8. So 8, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45, 46, 47, 48. Do each of them have 8? Yep. Did I get to 48 milliliters? Yep. So if I count the boxes, that should tell me how many friends poured water or 8 milliliters into each of the beakers. Make sure I represent this properly. 8 milliliters, each one equals 8 milliliters. So let's count how many friends poured 8 milliliters into this beaker. 1, 2, 3, 4, 5, 6. 6. So F for friends equals 6. 6 friends. Is that what we wanted to or needed to answer our question? Thumbs up. That's definitely what we needed. So let me go over the steps again. All right. First, we found out what Tanner started with in his beaker, then what he ended with in his beaker. We also knew that each friend put 8 milliliters in the beaker until it got to 93. So the first thing we did was subtract how much he ended with from how much he started with, and we found out that there were 48 milliliters that they added into the beaker to get to 93. So now that I have 48 and I knew that each of them put 8 milliliters, I simply put 8 milliliters in each square until I got to 48. All right. I remembered that if I have 2 columns of 4, that was 8. So I counted. I didn't start my count over every time I did a new box. I kept on going because I needed to get to 48, and I just used my smart brain to remember what 8 looks like with dots. So I counted 8, 16, 24, 32, 40, 48. And so after putting 8 in each box, all I had to do was count the boxes because I know the boxes represented how many friends Tanner had pouring water into his beaker. And I know 1, 2, 3, 4, 5, 6, 6 friends. So my final answer was 6. My final answer was 6 friends. So remember, guys, these are multi-step problems. If you've only done one operation, if you just added and you think you got the answer, you probably didn't. These are multi-step problems. We got to be able to notice these guys because on a STAR test, on a MAP test, on a CA, it's not going to tell you, hey, we're doing multi-step problems here. So make sure you do 2 steps. So you have to read carefully to know what it sounds like or what it looks like in a word problem when you have more than one step. So for today's practice, you already know that you do, but in the future, guys, you have to read problems carefully to know if you have more than one step. Keep going until the question is answered and the problem is solved. Great job today, ladies and gents. I'm going to re-share my screen. I am going to leave the screen here on 1 and 2 because those are problems that you need to do. You need to, if you do not have your Blue Spine Eureka book, work them out on a piece of paper. You do not have to write the question, but you do need to have a model, a full complete model, and an answer. A full complete model and an answer. So I'm going to leave it here for about 1 minute. You're like, Mr. Mark, I can't do both of these problems in 1 minute. Ladies and gentlemen at home, just pause the video for yourself. If you pause the video, you can sit here and look at it as long as it takes you. Ladies and gentlemen that are at school, I know you all should have Blue Spine Eureka books, so you should not need to pause it because you can read it right out of your Eureka book. All right. So I've already started my timer. I'm going to give us about 30 more seconds to pause it. Pause it and work on these problems. They are going to help you when it comes to doing your Schoology assignment. All right, pause it if you need to. Pause it if you need to. I'm going to show you questions number 3 and 5. Remember, you're doing 5. If you have extra time, come back and do 3. I'm going to stop here for about 30 seconds. Like I said, pause it if you are at home. If you're at school, you have your book, so you will not need to pause this part. All right, guys. If you are at home, like I said, you should have paused this. You should be working on this for yourself. If you're at school, the video is about to end, but I know Ms. Crawford is going to allow you to finish these up before she allows you to get on to Schoology to do the classwork or the homework for today. That looks very similar to what we're doing here. So finish those up, guys, and after you're done, you will log on to Schoology and you will finish the classwork. But please finish this problem set first. It is imperative and it's going to help you get some extra practice that you need before you log on and do it, the Schoology work. All right, ladies and gentlemen, well, it was nice teaching you virtually today. Sorry I could not be with you live, but I will return to you guys tomorrow. Have a great rest of your day. If you're at home, make sure that you're locked in, attentive, and focused on what Miss Crawford has to teach you this afternoon. If you're at school, you know my expectations for you. You know you will be rewarded if you do properly, if you behave properly. You know that there will be consequences if you don't. So make me proud, ladies and gentlemen, so I can bring you a reward. All right. You guys have a great rest of your Monday, and I will see you all tomorrow.